Metal casting process is defined as the process in which molten metal is poured into a mold that contains a hollow cavity of a desired geometrical shape and allowed to cool down to form a solidified part. Metal casting processes have been known for thousands of years and have been widely used for creating sculptures, jewelries, weapons and tools. During the Bronze Age, metal casting exploded in popularity. Bronze was a much easier and stronger alloy to work with compared to gold, and was cast into tools and weapons using stone mold. Discussing the different types of metal casting process in engineering and industries. Do well to watch the video till the end. Kindly support the channel to grow by Types of metal casting. Metal casting can be divided into two major groups by the basic nature of the mold design. They are 1. Expendable mold casting, 2. Non-expendable or permanent mold casting. Expendable mold casting. Expendable mold casting is a method that utilizes single-use or temporary molds to produce the final casting, as the mold will be broken to get the casting out. Sand, ceramics, and plaster are common materials used to make these molds. They are generally bounded using binders to improve the qualities of disposable molds. Expendable mold casting can be used to cast complex, sophisticated shapes. Types of expendable mold casting. The expendable mold casting is divided into two: the permanent pattern and the evaporative pattern. The permanent pattern uses a permanent model to create the mold pattern. Examples includes sand casting, plaster mold casting, shell mold casting, and ceramic mold casting, while evaporative pattern uses temporary model which will evaporate to create the mold pattern. Example includes lost foam casting and investment casting. Sand casting. This is a casting process by which sand is used to create a mold, after which liquid metal is poured into this mold to create a part. The first step in the sand casting process involves fabricating the pattern, the replica of the exterior of the casting for the mold. These patterns are often made from materials such as wood, plastics, etc., and are oversized to allow the cast metal to shrink when cooling. Cores are internal mold insert that can also be used if interior contours are needed. The second step is the process of making the sand mold from this pattern. The sand mold is usually done in two halves, where one side of the mold is made with one pattern, and another side is made using the other pattern. The top part of the mold is known as the cope, and the bottom half is the drag. And both are made by packing sand into a container around the pattern and rammed. After ramming, the pattern are removed and leave their exterior contours in the sand, where manufacturers can then create channels and connections, known as gates, runners, into the drag, and a funnel in the cope, known as sprue. This gate, runners and sprue are necessary for an accurate casting, as the runner and gate allows the metal to enter every part of the mold. The sprue allow for easy pouring into the mold. Advantages of sand casting. It has a low setup cost and is cost effective. Ideal for short production runs, as the lead time to make the mold is short. The value of the equipment is low, as it regularly includes simply sand and reusable pattern. Sand casting can create very complex parts, if the right cores and gating system are used. Disadvantages of sand casting. Creates a high degree of porosity in the metal, causing a low final part strength. The surface finish out of the mold is poor and must be cleaned. Low dimensional accuracy. Defects are unavoidable in sand casting. Secondary machining operations is often required if tighter tolerance is needed. Plaster mold casting. Plaster mold casting is a metal casting process which is similar to the sand casting process, except that the molding material is plaster of Paris instead of sand. It is generally used for casting non-ferrous metals. Steps in plaster mold casting. The powdered plaster of Paris is mixed with water to form plaster. Additives like talc and silica flour is added to the plaster of Paris and water mixture. The mixture is then poured over the casting pattern. The slurry is kept for around 20 to 25 minutes, so that it sets properly before removing the pattern. The pattern used for the plaster molding process is either made of plastic or metal. Wood patterns are not preferred, as wood shows tendency to warp when it remains in contact with the moist plaster for a longer time. After this, the mold is separated from the pattern, and it is baked at temperature between 120 to 260 degrees Celsius. The baking is done to remove the moisture content from the mold and gives it strength. Finally, the molten metal can be poured in the mold cavity. Advantages of plaster mold casting. Very good surface finish is obtained and machining cost is reduced. Slow and uniform rate of cooling of the cast is achieved. Manufacturing of complex shapes is possible at less cost. Good geometric accuracy can be obtained. Disadvantages of plaster mold casting. Cannot handle temperature higher than 1200 degrees Celsius. The mold preparation and setting of plaster consumes more time. If the moisture content is more in the mold, then it will cause casting defects. The production rate is low due to the longer time for solidification. Shell mold casting. Shell mold casting process uses resin-covered sand to form the mold. It is used for small to medium parts that require high precision. Steps in shell mold casting. A heated match plate or cope and drag pattern is placed over a sandbox mixed with a thermosetting resins. The box is then turned upside down to allow the sand and resin to fall onto the hot pattern. This creates a partially cured mixture to form a hard steel on the surface of the pattern. The sand shell is cured by heating in an oven for several minutes. The shell mold is then removed from the pattern. The shell mold's two halves are assembled, and pouring and casting is completed. Advantages of shell mold casting. Good surface quality. High dimensional accuracy for complex casting. Less than 5 mm wall thickness is obtainable in shell casting, in comparison to sand casting. Less manpower and molding skill requirements. Disadvantages of shell mold casting. High production cost. High pattern cost. Size and weight limitations. Ceramics mold casting. Ceramics mold casting is very similar to sand or plaster mold casting, except that the mold is made of refractory ceramic material. The ceramic material can withstand high temperature compared to plaster mold. Hence, it is used to cast materials such as cast steels, cast iron and other high-temperature alloys. Advantages of ceramics mold casting. Excellent surface finish. Closed dimensional tolerance. Thin cross-section and intricate shapes can be cast. Disadvantages of ceramics mold casting. Difficulty in controlling dimensional tolerance across the parting lines. It is expensive, as it has more equipment cost. Production rate is slow, because the mold preparation is time-consuming. Lost foam casting. Lost foam casting is a type of evaporative pattern casting. This method is quite similar to investment casting, which uses wax instead of foam in the pattern-making process. The lost foam casting uses a polystyrene foam pattern to create a sand mold. The pattern then vaporizes when the molten metal is poured into the mold. It is sometimes referred to as expanded polystyrene casting, lost pattern process or evaporative foam casting. Lost foam casting process steps. The polystyrene pattern is coated with a refractory compound. The foam pattern is then placed in the mold box, and sand is compacted around it. The pouring cup and sprue are formed by pouring molten metal into the portion of the pattern that forms the pouring cup and sprue. Poured molten metal vaporizes the polystyrene pattern as the metal enters the mold, filling the resulting mold cavity. Advantages of lost foam casting. Guarantee high precision and smooth surface finish. Guarantee nearly no error or defects in casting, more economical than investment casting. Casting of very complicated parts is possible. Disadvantages of lost foam casting. The pattern cost is high for low volume applications. It can easily get damaged or distorted because of its low strength. Investment casting process. In investment casting, a wax pattern is coated with a refractory material to make a mold, which is then melted away before pouring molten metal into the cavity to solidify. Investment casting is also known as lost wax casting. Advantages of investment casting. Parts with extremely complex shapes and intricate feature can be casted as a single piece. Short length or shallow depth features can be casted without cold shut defects. Has excellent dimensional accuracy, and tighter tolerance are easily achievable. Can achieve an excellent surface finish without any post-processing. Disadvantages of investment casting. Parts are difficult to cast if they require core. Limited to large production quantities due to high cost of dies to make patterns. It involves many complex steps, making the process relatively expensive. Non-expendable or permanent mold casting. Non-expendable mold casting uses permanent molds, which can be reused after each production cycle. Although permanent mold casting produces repeatable parts due to the repeated use of the same mold, it can only produce simple casting, as the mold needs to be opened to remove the cast. Examples of permanent mold casting includes pressure die casting, gravity die casting, centrifugal casting and continuous casting. Pressure die casting. Pressure die casting is a process in which molten metal is forced under pressure into a securely locked metal die cavity, where it is held by a powerful press until the metal solidifies. After solidification of the metal, the die is unlocked, opened, and the casting ejected. After removal of the casting, the die is closed and locked again for the next cycle. Two types of system are used for injecting the molten metal into the die: the hot chamber system and the cold chamber system. Advantages of pressure die casting: ability to produce high volumes of identical metal components with high level of accuracy. Cost-effective solution for the mass production of castings. Can produce thousands of components before needing to be replaced. Closed dimensional control and good surface finish. Disadvantages of pressure die casting: requires complex and expensive equipment. A large capital investment is required for the setup. Relatively inflexible when compared to gravity die casting. Possibility of porosity in the cast due to air pockets. Gravity die casting. Gravity die casting is one of the oldest methods for metal or metal alloy casting. Here, the metal is poured inside the cavity in liquid form using a ladle or a vessel. The cavity hole has to be on the top surface. There is no external force, but gravity that fills the cavity after pouring the molten metal. The metal is transferred manually or automatically into the mold. Sometimes it is necessary to tilt the die to control the pouring. Manufacturers use sand cores to keep holes or pores in the casting part if necessary. Advantages of gravity die casting: good surface finish, tight dimensional tolerance, thin casting can be produced easily, ideal for mass production, take small floor space. Disadvantages of gravity die casting: high initial cost of the mold, not suitable for casting metals with a high melting point. Centrifugal casting. Centrifugal casting is a permanent molding process, which makes use of centrifugal force to fill a mold with molten material. There are three types of this process: centrifugal casting, semi-centrifugal casting, and true centrifugal casting. The principle is the same for all the three types. The mold is rotated around an axis, and molten metal is poured into the pouring cup, from where it is forced into the mold by centrifugal force. Advantages of centrifugal casting. Casting acquire high density, high mechanical strength and fine-grained structure. Inclusion and impurities are lighter. Gates and rises are not needed. High output. Formation of hollow interiors without cores. Disadvantages of centrifugal casting. Inaccurate diameter of the inner surface of the casting. Not all alloys can be casted in this way. Continuous casting is a manufacturing process that allows metals and metal alloys to be shaped, then solidifies without interruption. The molten metal is fed into a mold of the required shape. Heat is extracted from the metal by placing cooled water around the mold. The metal is given its base shape and it's partially solidified. The semi-solid metal is then sent through a guide that will stretch the material to the required thickness. The metal continues cooling in this stage, and the fully solidified metal is set through straighteners to achieve the final dimensions. Advantages of continuous casting. Perfect for pressure applications. Less material is wasted than some other casting method. Less machining is needed. Same product can be gotten every time. Disadvantages of continuous casting. High cost of setup. Not practical to use this method for small quantities, or for special